Hi, thanks for being here. My name is Tim. I run developer relations at a company called Startree, and this is my second week on that job. This is a new gig for me, so you might recognize me from the Kafka world. I spent about 5 years there, and I definitely haven't left that world, the whole world of event-driven architecture. In fact, what I want to talk to you about today is a piece of infrastructure, an open source infrastructure component that I think complements the event-driven world in a very important way. I think there's this, as the world makes the transition to event-driven architectures, there's a bunch of things that are making a lot of sense, a bunch of things that are working well, and there are parts of the stack that feel like they don't exist yet in a stable way. And that's really what got my interest when I took a look at Pinot and why I'm doing what I'm doing. But we'll get to that. This talk is an introduction to Pinot, and as it turns out, I think where we are in the history of real-time analytics, it doesn't, I don't think it's super interesting to do a bunch of deep dive into how this particular database works. I don't know, there's some cool stuff in there, and we'll talk about some index types and things that I think actually are useful. But this is not that talk, like here's how you build a distributed database. It's more about why Pinot is the thing that it is and what place in the world does this kind of infrastructure really have for us. And the story starts, at least as I like to tell the story starts with textiles. And you're thinking, well, that's obvious. We knew that. Go on. No, I think this is important. So we have, excuse me just a moment here. I need to fix a problem here in this keynote. Here we are. Okay. When you kind of look into the history of human beings using clothing, clothing is kind of a relatively necessary technology for us. Like as an animal, we're a fairly fragile tropical creature. There's this little narrow range of temperatures where you can survive without any kind of assistive technology like that. And human beings occupy parts of the planet that are well outside that narrow band. So like, as long as there have been humans, there's been clothing. Early clothing was just animal skins, and then people figured out how to make clothing out of plant fibers, and then things got fairly sophisticated. And when you get into, let's just say, pre-industrial Europe and Asia, an interesting thing happened. There was a economic bottleneck in the production of textiles, and that was thread. Thread was the expensive thing to come up with. This is in the pre-industrial world. Now, weaving itself, there were machines for that. They weren't mechanized, but there were machines that made weaving faster than doing things with a needle. But making thread was difficult and expensive, which led to spinning wheels. And spinning wheels became this thing that just existed in homes. And it was work that mostly women did when they weren't doing the other kinds of work that in that period and in those economic groups and so forth that women normally did. Like they're not caring for children, they're not doing agricultural duties or duties in a shop or things like that, regular kind of household production kinds of things. They would spin. This became a thing that you could do in your spare time. You could hang out with friends and you could spin. And the reason for that was because there needed to be a lot of thread produced to satisfy the demand for textiles. And it was expensive time-wise to make that thread. So it was a thing people did with spinning wheels. Now, these days, spinning wheels are a consumption good. Now, my middle daughter, if you follow me on Twitter, you know she just had a baby 2.5 weeks ago, and I haven't seen him in a week and a half. And when I see him this Saturday, he's going to be entirely different than he was 3 weeks before that, because you know how babies change a lot in the first few weeks. My middle daughter, who you may not know, she has a spinning wheel in her home. Like, she buys clothes at Target and things. She's a relatively normal person, and those clothes are manufactured through industrial processes. But she has a spinning wheel because she thinks it's cool. She has a couple different kinds of spinning wheels. So they're a consumption good now, and they were made that by the Industrial Revolution. When the Industrial Revolution industrialized the production of thread and then industrialized the weaving process, The key thing there wasn't the reduction in the cost of weaving, but the reduction in the cost of thread. All right, so prior to that, as a working class person, that's a slightly anachronistic term when we're looking at pre-industrial Europe, but as a working class person or say a farmer or something like that, you didn't own a lot of clothing because it was really expensive because it was hard to make thread. Where is this story going? Well, it was hard to make thread. That process was distributed. Lots of people did that, contributed to that process. And so you wouldn't use textiles for much. But when that process was industrialized and became much, much, much cheaper to make thread, did people just buy more clothes? Well, yeah, you could have more clothes. But if it's like orders of magnitude, if it's 10 to the 4, 10 to the 5 times cheaper to make thread now with machines than with spinning wheels, you don't need 10,000 times more shirts. That just doesn't happen. You don't do that. So what happens is people come up with new things to do with textiles. Let me give you an example. When I buy USB or charging cables of any kind, Lightning, USB-C, USB, it's kind of this matrix, three-dimensional grid of charging cables we have to maintain now. I don't like these that have a textile on them. Now, it's kind of hard to avoid. Many of them come this way, but this $5 charging cable comes with fabric on it. So fabric gets into places where it wouldn't have gotten into before that many orders of magnitude cost reduction in the unit, the unit economics there of the thing. Textiles are everywhere. They're not, and this is a weird thing with charging cables right now, power cables generally aren't covered in cloth, but if you look at an antique power cord, say from the early 20th century, generally there is a fabric sheath there. So once industrialized, fabric got everywhere because it became several orders of magnitude cheaper to do the thing that, the basic unit that you had to do to make the thing. This is the same story with user-facing real-time analytics. What has happened, what Pinot does, is change the economics of an analytics query by several orders of magnitude. The result isn't that you have 10,000 times more dashboards for 10,000 times more executives, or that the report that maybe took a minute to create now only takes a millisecond to create, and that's somehow interesting. The minute was fine. Nobody cared that it took a minute. So when we get this orders of magnitude reduction in the cost of the unit of the thing that we're doing, reduction in our unit cost, we end up doing different things with that unit. That is the story of Apache Pinot. Let me go on. And actually try to draw some more concrete connections. Talk about a history of analytics. I like to start this history, and you know the song, Billy Joel song, "We Didn't Start the Fire." It's like all these things in the 20th century, super fast paced. If you don't know it, you should look it up. It's great. I remember as a kid, as a teenager in the 80s, thinking, "Oh, this is just about like the human experience, man." And well, it actually starts with his birthday. Okay, so it's more like the human experience over Billy Joel's life. And I tend to start thinking about the history of analytics around 1990, which is a little bit before the beginning of my professional life, but not long before the beginning of my professional life. So this could be conditioned by me. But I like to think about kind of 1990-ish. Relational databases are getting established, and what we now know as ETL and things that are now slightly old-fashioned, all of those practices were being developed in the 90s. Inman and Kimball, those guys were writing their books, building their consultancies, and this was game-changing stuff. But what analytics did back then was, the idea was to prepare a printed paper report. Like you see, that's a very important person holding a printed paper report. You want to imagine an oak paneled office and an important chair, a person who's dressed well, gets paid a lot of money. In the morning, they're prepared a report. That report is given to them. And what are they able to see? The activity of the business from the previous day. And that was game-changing. It sounds old-fashioned now. In fact, if you are a DBA of that stripe or an analytics person, and you talk about data warehouse, meaning like a legacy kind of data warehouse, it's like kind of us saying monolith. It's a little bit embarrassing. You have a monolith, but no, there's a reason for it. Or, well, we're trying to fix it. It's this technology still hanging around is not really a thing that you still want. But it's there, and it was super important at the time, and game-changing, and analytics was delivered to people at the top of the org chart. And it was a report, and it could take overnight to generate, and that was fine. Now, over time, this kind of gets driven down to the individual worker. And this is definitely a movement that's happening where analytics need to be more and more available to people down the org chart and not just at the top. If you listen to people who are talking about data mesh now, they underscore this point firmly that analytics products need to be available to people throughout the organization. That's certainly a thing that's happened. It's getting pushed down. And as it gets pushed down, the overnight timing doesn't work so well anymore, right? We need things to go faster. I think a slightly more systematic taxonomy would help here. So let me draw a quadrant. We definitely need a quadrant. And there are kind of 4 customers for analytics here. We have people I'm going to call analysts. Now, that's a broader term. That includes that executive I showed a picture of just a minute ago. All right, so that executive is an analyst. People I'm going to call operators. These could be, I showed you a factory worker, somebody operating equipment and needing to know what's going on with that equipment and needing access to analytics information to look at right now. It could just be an individual contributor in the business, a person doing things, right? And then we've got people who are customers of the business, and I'm going to create another category called users, and they may sound like the same people, but I will differentiate between them. So, and I got some use cases that I want to dive into to illustrate what I mean when we're done with this. Now, the freshness of the data, the amount of people accessing the database, and the latency that they're sensitive to, how long queries should take, change in all 4 of these cases. And in 2 of these cases, we have an established legacy tool set, which has continued to evolve, right? We're not building data warehouses like we were 30 years ago. But that tool set has moved on and evolved to handle one half of this, and the other one is really space that I think Pinot wants to fit into. So let's look at this. For analysts, for those executives, they can have batch data. Yesterday is good enough. Maybe even a few hours ago is good enough. That's fine for them. There are probably tens of people using this kind of database at a time, depending on the scale of the business, but it's something on the order of 10. And query execution times in the order of minutes. So we'll say that's 10 to the 2 seconds, right? That's 100, 200 seconds, something like that. If a report takes that long to generate, feels a little old-fashioned, but it's okay. The kind of thing that we're trying to do here, even if it's a dashboard, if there's some cache data, that's fine. Operators, they are probably interested in something a little fresher. They don't want to know what's happening yesterday. They're trying to make decisions about their job today, usually is how that works. There are more of them, so concurrency increases. There will be more people hitting the database at a time. But from 10 to the 1, 10 to the 2, that kind of order of magnitude, nobody's freaked out, right? We have databases that do that. That's fine. And latency on the order of seconds, 10 to the 0 would be like 1 second, 5 seconds, 9 seconds, something like that. That works for those operators. Let's move over to customers. And I'll differentiate between customers and users in a minute. But they really are going to want to know, these are people outside the business. They're going to want to know what's going on right now. They have real-time requirements. And there will potentially be thousands, maybe tens of thousands of them. This population starts to scale up a little bit. And they kind of need pretty quick answers. They're going to want something on the order of hundreds of milliseconds, probably, if they want to know what's going on with the business. I'm going to get into this use case in a minute, but imagine the business is something like Uber Eats. Uber Eats is a big Pinot user, an important Pinot use case right now. A restaurant manager would be an example of a customer, right? There aren't many of them. There are not millions of them. There are a lot of them, and they want pretty accurate, up-to-date information. They want to know, is a spike of orders coming? Do they have to change things? Did they have a special that was running? They're about to get slammed. They have to stop the special in the online. So something like that. They're trying to make decisions about right now, and they really need pretty fresh data. And there are a lot of them, but not too many of them. The population of users absolutely want real-time data. We expect that. There are millions or tens of millions of these potentially for a service that scales up. We need to be ready for a lot of people. And they also expect millisecond latency. Again, if you think about the Uber Eats use case, if I'm looking at the app, I want to know delivery time, right? I want a burger, and I'm hungry. This was last night after I landed. I got to a bar. Some of you were in that bar, and I really wanted a burger. And the latency was on the order of 10 to the 2, 10 to the 3 seconds, really. It was like a third of an hour. It was a long time. But if I'm ordering food, I want to know what the delivery time is going to be. So this view of restaurants on my phone will show several burger joints near me that are within ordering distance. And for the app to be able to refresh those views, it has to be doing several queries to tell me the delivery times for those restaurants. Therefore, those queries, in order for this app to feel responsive and not feel like a piece of garbage, those need to be kind of on the order of 10 to the 1 milliseconds, or 10 to the minus 2 seconds. Tens of milliseconds is the query latency that has to happen there for true user-facing real-time analytics. And there could be tens of millions of me hitting the database, tens of millions of me in the population of users doing hundreds of thousands of queries a second. So over here on this side, this is what I'm now calling internal analytics. What historically we've called simply analytics, right? It's the report, it's the dashboard. We have an existing set of tools to handle that, and that set of tools has been, frankly, pretty successful. You've got the old school data warehouse, and where does that go now? Well, now that data warehouse is in the cloud. You have Snowflake, right? Snowflake has been a profoundly successful cloudified data warehouse, taking all of those concepts, all of those internal analytics use cases, and making them a successful cloud service that operates the way you'd expect it to operate and works real well. And as always, when we're talking about a changing technology paradigm in a new category, it's never our job to say that old thing is bad. It's not, all right? And frankly, if you look at where Snowflake trades, if I were to say Snowflake was bad, the joke would be on me, because clearly this is a thing a lot of people really love, and it works very well. But that is for the internal analytics case. Other things, BigQuery would be like the Google thing that seems to dominate in the clouds and their cloud internal data warehousey things. BigQuery is always the one that comes up above Azure and AWS. Presto would be another layer that you can run to run SQL queries on top of, wherever fine data is sold. Presto will run SQL queries on top of that. Spark SQL, if you're using Spark or something like it, that's another way of doing SQL. All of these have the freshness and concurrency and latency characteristics that push them toward the internal side of the house. And I need to stress again, they are not bad, they're good. They're good and worthwhile products that serve that side of things. When we come over here, well, we have to do something different because those just aren't going to work. This is where Pinot wants to live. But hey, before we dive in and get to Pinot, there are some other questions, and I have a font size problem on that slide, and I apologize for that. That is looked fine earlier, and I'm just realizing that's just not. So get your phone out and take a picture and zoom in on the picture so you can read that. We could just kind of look at our options. I've said that the data warehouse things, Spark SQL, Presto, BigQuery, Snowflake, all those guys are high in latency, certainly very high in flexibility. We've got, they're more or less ways of executing SQL queries on top of big sets of data. They all scale to where we need them to scale, but they're slow, all right? In the middle, you can do things with, say, document search, like Elasticsearch. You can get some very fast document retrieval times, but you have a little less flexibility there, right? It's not doing as much for you. If you want to compute an aggregation, you have to do a bunch of document search and then get the documents and aggregate them, compute that aggregation yourself. And so you're going to end up paying in latency because you're going to have to repeat operations more. And that's just parts of the stack that have moved up into code you're writing, and you don't want that. On the extremely low latency, low flexibility end of things is just think of a key value store. If I say, well, this needs to be super low latency, it's okay, let's just pre-compute everything and put it in a key value store. That will work. You can get the latency characteristics you need, but this kind of data tends to be highly dimensional, meaning it's difficult to predict ahead of time what pre-computation you need to do. And if you want the latency advantages of a key value store, you have to do basically like one key lookup. And that means you have predicted that that was the query that you were going to run. You have done whatever pre-computation you needed to do, and it's just there in the value, and you can fetch it. That's hard to do because what do you kind of end up doing there? Years ago, I used to talk about Cassandra a lot, and Cassandra is not a key value store, but it behaves like a key value store in this way. And in Cassandra data modeling, if you know Cassandra, there's a sense in which you are building your own indexes. The way you model data, you're thinking about the way you're going to read the data. That's very much the case if you tried to do real-time analytics in a key value store in a roll your own kind of way. You have to think about the read patterns, and you are essentially building indexes when you do that, which may not be the business that you're in. And that is the ironically understated may. It's definitely not the business you're in. You don't want to do that. That's like if you find yourself solving a distributed state problem and you're not distributed in infrastructure. This is a hint. You shouldn't be doing that. What we would like is something with a high ingest rate, horizontal scalability, millisecond query latency, and SQL. We would like not to have to think too hard about the infrastructure. You know, there is a pretty good database data model that's available to us and query language that's available to us. We'd kind of like to stick with that. That's tables and that's SQL. And there have been, in the last 15 years, attempts to kind of find off-ramps from that world. I mean, that was 2010 and the NoSQL revolution. Ended up not being a bad idea. There were all kinds of good ideas that came from that, but most of them, kind of with the exception of Mongo, most of those early departures from SQL ended up growing a SQL interface anyway. It's this thing that we just can't get away from. So in the case of Pinot doesn't even try. And there is no, here's the Pinot API part of this talk, because you already know it. I don't need to explain to you how SQL works. It is just that. So that's kind of what we'd like. And you notice in this diagram, there is kind of this, as we go around from analysts to users, life gets harder and harder, and the legacy tool set becomes less and less useful as we end up on users there. I kind of gave you a little bit of a preview of a key use case just to illustrate that diagram, but let's talk about some other ones right now. Pinot comes from LinkedIn. There are lots of great projects that come from LinkedIn. Kafka came from LinkedIn. And Pinot came from a related team doing related things. And I'm going to come back to that in a minute, actually. I think there's a super important insight in the connection between Kafka and Pinot. But anything you do on LinkedIn is, of course, using Kafka to store the data, to manage events, and also there are multiple Pinot queries happening. Just to refresh your feed, you know when you go to LinkedIn, I don't know if you use LinkedIn much, but I'm a complete social media addict, so LinkedIn is one of the things I look at on a regular basis all day long. And if you go to your feed, you see things and you hit refresh, you will see completely different things. And that's like what Facebook started doing 7 or 8 years ago, you know, with newsfeed algorithm optimization and all kinds of things that are related to that. Facebook is less obvious, though. I mean, if you just refresh the Facebook page, you might see some of the same things. If you do, I recommend you try that with LinkedIn. You will see very different things. And that's because that view of your feed is a real-time analytics query output. And one of the inputs to that is, what have you seen recently? And so Pinot is telling the code that's generating that feed, well, she saw that and that and that, so we don't need to see those again. Those are less preferred. They should be down the list. So all that's true. Who viewed my profile? I believe this is where this was the first Pinot use case, because there was like no good way to do this in real time. This used to be stale data, but this is very up-to-minute data these days. And you've got thousands of queries per second on this page, and under 100 milliseconds P99 latency on the query. So it's a real thing. I'm curious. There are not many of us in this room. Does anybody look at this view in LinkedIn? Hands? Don't be ashamed. Do it. All right. I think it's just become a premium feature, so I don't have as much visibility into this because I don't pay for LinkedIn. But maybe I'll start because, hey, I like to know. The feed itself, like I said, same thing. It needs to know what you've seen recently, and you don't want to see those things as recently. I talked about Uber Eats. This is the restaurant manager view. So this in my 4-part quadrant, this was a customer, the restaurant manager. Still, this is external analytics. This is somebody outside the organization, but somebody of whom there are fewer than there are actual users. And there's still 500,000 of these people, a lot of them in the case of Uber Eats, hundreds of queries per second, and still sub 100 millisecond latency. This slide mentions freshness as well. So we'll talk about ingestion into Pinot in a minute, because we'll talk about ingestion in a minute. But once data is ingested, once that process is completed, it's available for querying. So it's not like there's an ingest and then it needs to get rolled up and spun off to a segment and everything. That's ingestion means it's queryable. That seconds to minutes speaks of system-wide. So there is some streaming event pipeline where things are happening with whatever it is the restaurant manager needs to know. And that could take seconds to get through that system. Or there could be some bottleneck in that system where maybe there's stuff that takes a minute to get into Pinot. Once it's in Pinot, it's queryable. And as it makes its way through the streaming pipeline, that's where you see the freshness. For a new technology like Pinot, if I didn't show you a logo slide, it would just not be a good thing. So we have to look at logos. This is what you do. Obviously, LinkedIn, that's where it started. Guitar Center. You notice Guitar Center on there? Any Guitar Center customers here? I am not one. Okay, good. These guys and their technology game, I mean, I actually don't know them. I haven't met the folks who run the stack at Guitar Center, but everywhere I've worked, they're always doing some leading edge thing. So for a store that's not some incredibly recognizable national brand, if you're not a musician, they're really on top of things. Other big ones, Walmart, Stripe, allegedly like every transaction in Stripe is ingested into Pinot and queryable from Pinot. Target, again, not a surprise if you know Target. Uber has been a substantial contributor to Apache Pinot. The geospatial index type exists because of work Uber has done, and plenty of others. Also really international. The footprint is a lot less North America focused than I normally see. Like there's a lot more activity in India with respect to Pinot than I've seen, say, with Kafka or Cassandra or something like that. So always nice. Growing community, Slack workspace. There's a cloud, Startree has a cloud service that is actually already up and running and serving customers and growing in data and queries and all kinds of stuff, and it's good. All right, let's look a little bit up at Pinot's architecture. Now, before we look at Pinot's architecture, I just want to talk a little bit about architecturally how Pinot fits into the world. And I've given you big ideas, and I think you understand kind of my taxonomy of analytics and why. And I think that's all pretty persuasive. But okay, I love this phrase. In the modern data stack, the modern data stack. How many modern data stacks are there? Well, that depends on how many speakers you have creating presentations about the modern data stack. The cardinalities are the same. So everybody talks about the modern data stack, and what they mean is the thing I just built. With relatively new tools, and they're not all the same. It's super interesting, right? I don't think that we need a moratorium on the use of the term or anything like that. I am keenly interested in everyone's take on the modern data stack because people are building good things and smart people are solving problems in interesting ways, and it's fun to talk, but there isn't one of them, okay? I think that's important. There's lots of different ones, And Pinot is able to plug into a lot of them. I'll talk about an event-centric architecture first, just because that's kind of where my heart is, and that's the thing. It's been years telling people, hey, event-driven architecture is a good idea. You should build systems this way. And I don't think I was wrong. So in your basic event-driven kind of world, where you've got a number of services that interact with one another through probably Kafka topics. In most cases, it's Kafka topics. Pulsar would work fine as well, but you could even use Kinesis if you were so inclined. But most of the time, it's Kafka, right? There's Kafka storing events, services interacting, microservices consuming from one Kafka topic, doing some computation, producing into a new Kafka topic, and sagas kind of unfold through the system in that way. We get all that. That works super well. There are all kinds of characteristics to that architecture that help deliver on the promises people have been making about microservices for a decade, and it's generally successful. I've said before, I think that is a generation-sized paradigm shift, and I think when I am old and a great-grandfather, and people who are right now learning how to eat and go to the bathroom by themselves, then we'll be building systems that are probably recognizably event-driven systems, right? I think it's that long of a paradigm. Because we've kind of been on the client-server kick since I was a teenager, even through the web, right? That important changes happened with the web, but fundamentally, that's still just a reprise of client-server. The event-driven revolution is the first real change, I'm saying, since the 80s and how systems are built, and I think it's real, and I think it's I know it's happening, and I think it's going to endure for decades. There are some things going on there that I don't think are properly addressed yet. And when you have a new paradigm like that, it's enabled by some ideas and some infrastructure. And Kafka is that infrastructure, and microservices, and to some degree, certain deployment automation technologies, and those are the ideas. So you got your event-driven system, and the services interact, and they trade events, and they know what's happening right now, and that's great. And then you need to answer questions about state, right? What is true in aggregate about what has been going on? And when you've got this new infrastructure layer that enables this new way of building a system, certain things are bumpy, and answering a question based on like a key lookup about what's true right now is still a little bumpy in the event-driven world. It feels like you have to build stuff in your application. So here's this new infrastructure layer. Good, I'm not building a distributed log anymore. Here's my differentiated application functionality. And here's this fuzzy region of stuff in here that maybe I have to create in addition to my application. And it's not obvious in the early days of the revolution where infrastructure should be taking up that layer. There's this middle section of code I'm writing that maybe I shouldn't. Maybe it's not differentiated. The differentiated stuff is how I take care of my customers, how I operate, how I do my business differently than my competitors, all that stuff. That's always you, right? Nobody can take that away from you. Distributed log, please don't do that. Very bad idea to write your own one of those. Okay, you have several to choose from. Please use one. In the middle, okay, I use a topic to keep track of user accounts, because that's a super cool event-driven way to do it. I've got this like changelog way to do it. How do I materialize that into a database I can do reads on? Do I use Kafka Connect and dump it into Postgres? Do I use KSQLDB? Do I use Kafka Streams and build that into my service? Feels like I'm writing a lot of code to do that. And all of these technologies, again, are very, very good things that have places where they're absolutely the right way to do it. But it's not obvious how to do analytics on this data. That part of the stack is still fuzzy, all right? And we end up rebuilding a lot of stuff that we shouldn't rebuild. That's not the differentiated cream on top of the application that actually changes business results. It's probably something we shouldn't be building. That is my other perspective on why there is a Pinot, why I think there is an Apache Pinot right now. Because I think there's a part of that infrastructure layer that we're kind of hacking and building and doing our own thing those of us who are ahead of the curve on event-driven systems, and the layer of what gets done by infrastructure needs to move up and catch up with us so we don't have all that work to do. And I think that's what Pinot is. And eventually, in a mature paradigm, you've got mature products and services and all these things with all the features, and you just kind of plug in a little bit of code, which still ends up being a lot of code and really hard to do because code always is. But you're not rebuilding the stack. We're just in this transitional phase right now where we have to do that. And I think Pinot is over there looking at you saying, I'd like to love you and help you with these things. And you just have to let it. So anyway. Three parts to how Pinot fits into your system, whether it's event-driven or not, because by the way, it doesn't need to be event-driven, don't care. You could have a data lake full of stuff that you're just not happy with query times on, and you want to ingest from a data lake. That's fine. I mean, that's batch data, so it's not going to be super fresh, but you'll be able to do faster reads on that data. You could have a completely traditional relational database and monolith and want to be able to do real-time analytics on the data, the OLAP data in the OLTP data. I will die an old man and not get those right on the first time, OLAP and OLTP. I also can't really do left and right. I have to do this. I think in both cases it's something neurological. Maybe I'll get a diagnosis. You could have a very traditional OLTP database and a monolith and still attach Pinot to that. It does not have to be some space-age Kafka event-driven thing. It's fine. Pinot doesn't care where your data is. Point is, you ingest from somewhere. There's the data here that the business is operating on, or that you have let pool into a data swamp or data slough or data wetlands or lake or whatever it is you want to call it. You can ingest from there. Now here it is in your database in Pinot, and on the other side you've got applications reading Pinot. That's an important point. Ingest, Pinot, applications. So those users don't run queries against Pinot. Pinot expects to be serving queries to an application that's then exposing features like how long will it take this smash burger to send Tim his burger, or Tim can't figure out what to eat. Who near me has just ordered something and what have they? That's apparently a new. I don't do a lot of delivery. I guess I should start, but on Uber Eats apparently recently they've started exposing just near me who has ordered what. Can't decide what to eat? Well, oh, yeah, haven't had Thai in a while. Okay. That kind of thing. That app is issuing that query against Pinot. So you got ingest, database, Pinot, or application. Inside of Pinot, let's look a tiny little bit at what it looks like. We have a collection of, we call them servers, processes, whatever they are, but Pinot servers, and they're holding the actual data. Data is stored in structures called segments, and as data is ingested, it's written to segments that are stored in this, the segments are on the next slide, but trust me, there are segments in the servers. That's where the data lives, and there can be lots of different ways that that segment data is stored, but you've got segments on the servers, and then you've got another collection of structures, processes, we'll call them processes, called brokers. Brokers are what handle queries. They do the computation. So they'll get a query, and they will know by way of the controller, which uses our good old buddy Zookeeper to tell the brokers where segments are located in the segment store. Yes, Zookeeper's back. There isn't any discussion in the Pinot community that I'm aware of killing Zookeeper like there was for years with Kafka. Could just be a maturity thing. Maybe in another couple of years, they'll be saying, hey, guess what? We're getting rid of Zookeeper. We'll find out. These things tend to have a life cycle. But the brokers take queries from applications and scatter gather, because there are segments holding little pieces of the data everywhere. They send those queries to the servers and then get stuff back and return results. Dano. I'm optionally taking questions. Yes. The question was, I'm Trent Graham, the Independent. So that was a Ted Lasso joke. That makes me Ted Lasso, so I like it.
Yeah. So those servers are going to be redundant, so the data is
Yeah, question is data redundant, replicated? Yes, the answer is yes. Yeah, you know, so block diagram level, it's kind of what you'd expect a distributed database to be. There's a place where the data is stored, it's replicated, it's broken into these things called segments. There are brokers that handle the scattering and gathering of the queries. Ingestion can happen, can be done, ingestion gets done directly to the segment store, doesn't go through the brokers, so it's not like you're inserting data through brokers. This is pictured Kafka-aware ingestion, and the Pinot Kafka integration is, I'd say, particularly tight. So to ingest data into Pinot, if you know Kafka, you don't use Kafka Connect. That would be the traditional way of getting data from Kafka into a database. Kafka Connect is like the right way to do that. Pinot is basically its own consumer, and the reason for that is its consumption has a mapping of Kafka partitions to segments. So the partitioning of a Kafka topic and the segmenting of the data in Pinot in the segment store, those are equivalent. And there are some kinds of queries that are optimized that way. Other kinds, we've got index types that make those work. But it is its own consumer and doesn't use Kafka Connect. There are UDFs. You can write UDFs in Groovy, which I'm always happy to hear. But on ingestion, you can do bits of transformation, and there are other built-in ones for doing JSON extraction, date-time conversions, little bits of math. You know, as always, these are not huge amounts of computation that you want to do in a place like this, but there's always a little bit of cleanup. Data is always ugly. It's true. Okay, how much time do we have? Only a few minutes. In-depth discussion of the data model. Wait, it'll come to you. It's just tables. There really isn't much to say. It's just tables, and they have data types, they have rows, they have columns. They're exactly what you'd expect them to be, so there's not a lot to think about there. The query language, I don't even have a dorky slide for that. It is SQL. It's currently a substantial subset of ANSI SQL. Full join support is going to be a thing that is coming relatively soon. Right now, there's partial join support. So it just is like querying a SQL database, and that its SQL is converging on kind of unlimited regular old ANSI SQL. So, you know, again, talking about Pinot, it's not terribly interesting to talk about SQL. I mean, I think if I had a demo to live code or something, it's always fun to watch, right? Well, we do that kind of thing. Like, here's some cool thing that you can do with a big pile of data, you know. But you're writing SQL, and you're making tables, and that's it. And like, that's not interesting. And I think it is glorious that that's not interesting. And I just don't need to talk about it because we already know how to do those things. The interesting thing here is, what are you supposed to do? What is the problem that this thing is solving? And do I have that problem? Before we get there, a very quick look at the index types in Pinot. I feel like this is reductive, but in information storage and retrieval, kind of the money is in indexes, right? I mean, Dano, you asked a question about replication, and that's sort of bread and butter for data storage and distributed data infrastructure. It needs to be replicated. How do you do that? Well, here's how. Okay, you know, that needs to be a thing that it does. After that, you know, what's the data model? What's the query language? Those are interesting. There's kind of only one answer that we should give these days, and when we try to give an answer that's not tables and SQL, most of the time we rethink that and we get back to tables and SQL, again, with the notable exception of Mongo, which is a wonderful and very successful product, and that successfully departed from that paradigm. But you don't want a big collection of things that you just have to look through and find the thing and thumb through one at a time. That's pretty lame, right? That makes retrieval slow, and it makes aggregation a thing that's all on you. Which means indexes are kind of the money. That's what makes a database interesting. How are the ways you can index data? And this is, at some point, like I said, this is my second week in the Pinot community. At some point, I'd like to be able to just spend an hour diving into all the index types because they are so cool. And there are a lot, there are like a dozen of them. There are, first of all, there's the regular old, what's called the forward index, and that's basically like how to do a primary key lookup. Here's the thing, and that's where it is, go get it. The inverted index is, well, here's a value, where are all the things that have that value? So it's a quick way based on a value to get, which I guess is kind of what you normally think an index of being. A sorted index is, by implementation, a species of the inverted index. It's a way of getting, basically sorted ranges of things. There is specifically a range index for doing numeric range lookups on values, and these impressive bar charts are actually based on real results. We've got a blog post. If you just Google Apache Pinot index types, you'll get to a couple of star tree blog posts that have the numbers for these. And they're all true and a little bit straw man-y. They're like, well, if you just did a full scan, it would be like this. And if you use the index, it's, wow, look at that. I mean, of course, it's much faster, right? But that's the whole point, is that indexes are what you need to make a database be interesting. There's a text type that uses embedded Lucene. So you can do fuzzy text searches. You can do regular expression searches, all the kinds of stuff that Lucene will do. If you have a string type column with a bunch of unstructured text in it, you can do indexing on that with all the performance of Lucene. Startree, which now you know, Startree being a company formed to make a cloud service based on Apache Pinot and have a developer relations team that wants to make Pinot famous and all those kinds of things. This is an implementation detail that has leaked into the interface. So the name Startree is probably the coolest index right now that Pinot has. It's like making an index out of a pivot table, kind of. So if you wanted to index by country and browser, which if you could imagine, this is shown just as two columns, but in a pivot table you could have them as rows and columns. And then you get roll-ups in the cells in between there. Well, Startree index is a way of building that as an index. So it's lookup and pre-computed aggregation of fields that you specify. So you end up getting like freakishly fast retrieval and aggregation results that just don't seem like they ought to be possible because effectively they're pre-computed. And the database is doing that for you. In the table definition, you specify that you want a Startree index on these fields and you want these aggregates computed, and you get that. And it goes real fast. There's also a JSON index, so I can have, again, arbitrary lookups of arbitrarily nested JSON, the way you would want that to be. So if you've got a JSON field, you can query it, and it performs like you would expect an indexed field to perform, and you query that with, there's a JSON match function in Pinot's schema, so that you give the column name and then a little expression like you see there, addresses, street, blah, 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 and you get nice fast query lookups. And with that, I don't want to say thank you yet. You know what, here, let's just do this. Let's do this, okay. It's okay, it's supposed to be off, nobody panic. A few minutes left. Yeah, so again, like I was saying, I want you to think about where analytics has come, and there's been this substantially internal orientation, helping people inside a business make better decisions and be able to see more. And that work is never done. That's why there are companies like Snowflake. That's why, I hope I can say this without it sounding self-important. I talk to a lot of startup founders, right? There's no way to say that, sorry. There is no way to say that without sounding self-important. But I do talk to a lot of startup founders, right, who want to think about how to build a DevRel team and what to do and how to make this kind of thing happen. So many of them are analytics startups, you guys, so many, okay? A lot of that is this internally facing analytics orientation. And there's a lot of money there. There's a lot of activity there. There should be, because it's huge. But now also there's a need to expose what's going on in the business to the people using the service, using the application, whatever it is. So the question isn't, are you Uber Eats or LinkedIn, the social media, and those are, okay, I get those use cases. The question you need to start asking yourself is, what is going on inside of the business that you could expose to the customers of the business that would bring them into the circle of being decision makers? Decision makers aren't just well-dressed, well-paid people who get binders handed to them in the morning. Decision makers ought to include the people who are customers of the business, using it on the outside. And if there's state of the business that you can expose to them that enables them to become more effective decision makers, well, that means they will derive more value from the thing you're building, which means whatever it is they do to give you money, they'll probably want to do more of that. And they'd rather do it with you than with a competitor. I mean, that's just a good thing. So I think the transition that we're seeing now isn't so much a transition to event-driven architecture. That's happening. It's underway. We're starting to understand that. Pinot is also, in that sense, kind of filling in this hole in the infrastructure stack to make events queryable. If somebody asks you later, I went to this talk on Pinot, the guy went on for a little bit long, but he was cool. What's Pinot? They ask you. You say, well, it's like queryable Kafka. I mean, if you want 2 words, that's kind of a cool 2-word thing to describe it. It would have been a shorter talk. So yes, Pinot is that. But the fundamental change that I think we're seeing is we now want to expose the state of the business to the users of the service. How can we make their life better, make them better decision makers? And that introduces the need for this whole new kind of infrastructure. And I think that is Pinot. And I look forward to talking about this thing a lot more, hopefully with y'all. Thanks for being here. I can take one question. How much, what's the time frame of the data that you'll keep in Pinot? Yeah. So yeah, what's the, how old should the data in Pinot, how far back in time should the data in Pinot be? Yeah, old. So, like there isn't a, Pinot doesn't have a lot of opinion. It's going to be comfortable getting to petabytes and getting very large. Most people in like the Kafka world pick pretty small retention periods, days, right? And I always am bothered by that. Like a little part of me dies. I want to see longer retention periods just because I think more interesting things happen architecturally with longer retention. But that opinion in the Kafka world is pretty persistent. Those retention periods are small. That's not a thing in Pinot. Scale it, make it big, have all of the data there. There's an asterisk, please see legal counsel. I mean, lawyers have an opinion about how old the data can be at some point. It's not up to us. There are regulatory and risk management things there, but my answer is that should be driving the answer. What your lawyers let you do, not how big can the database get. So yeah, there should be a lot of data in Pinot. Say that again? Oh, major competitors for Pinot. Yeah, there are 2 open source things. One's called ClickHouse, one's called Druid. And just in the open source world, those are the 2. I think I saw one more hand, but talk to me after because we're at time and I don't like running over. Thank you very much for being here. And we're just about closed out. Enjoy the rest of Devnexus.